Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to learn algebra. Today is our lesson number 51. Lesson number 51. I'm going to quickly go over the course schedule. In the first 20 days we learn how to evaluate algebraic expressions. Then we learn on day number 21 through 50. Yesterday we finished learning about how to add and subtract algebraic expressions. And today we're going to start a new topic, how to multiply and divide algebraic expressions for the next 30 days from 51 through 80. Now, as always in the past from 21 through 50 and before also, in the beginning the problems are going to be very simple, very straightforward, and as we go higher up in the day, closer to in the 70s and high 70s and so forth, they're going to get a little bit more complicated. But again, I'm like a parrot, I keep repeating that if you really want to learn the algebra the way it should be learned, you mustn't skip any problem, you mustn't skip any videos, watch every single video in proper sequence, and make sure that you do every single problem, and you will get there where you need to be, which is to have the sound foundation for the algebra. You will know the elementary algebra that you need to know for any kind of college course or high school course. Here's the first problem. So we are learning how to multiply and divide algebraic expression. As I already said in the beginning, they're going to be very simple, very straightforward problems. So here's the first one. The question is, how much is 3x squared times 5x cubed? Now this is my multiplication sign, times, and this is my x. Keep it separate. 3x squared times 5x cubed. Well, 3x squared, 3 times 5 is 15. 3 times 5 is 15, and then we have to do x squared times x cubed. X squared is same as x times x, and x cubed is same as x times x times x. So altogether, we have 5 x's being multiplied together. 5 x's, 1, 2, 3, 4, 5. And the simple thing to remember is when you have a situation where the base is the same and you multiply the two quantity, all you have to do is add the exponents in order to multiply. So this is simply x raised to 5. So x squared times x cubed, x squared times x cubed is same as x times x times x cubed, which is x times x times x. So as you can see, there are 5 x's being multiplied together, therefore it is simply x raised to 5. So the answer here is very straightforward, very simple. We have 15 from 3 times 5 is 15, and x squared times x cubed is x to the 5th. That's it, that's the answer. Answer is 15 x to the 5th. It is read as x to the 5th. Now, when people say x to the 5th, what they actually mean to say is x to the 5th power. This thing is to be read as x to the 5th power, or x raised to 5, which I'll come to in a second. Let's erase all of this thing, we don't need it. We're learning right now how to read this thing, x to the 5th. Now when they say x to the 5th, what they actually mean is x to the 5th power. But they don't say the word power because the people are lazy. I'm lazy. So when somebody says x to the 5th, what they mean is x raised to the 5th power. This thing can also be this thing can also be read as x raised to the 5th power. X raised to the 5th power, or x to the 5th, or x to the 5th power, same thing. There are 3 different, 4 different, 6 different ways of saying the same thing. There are more ways of saying the same exact thing. I can't think of any right now, but as I think of some more, I'll tell you. But just like in any language, there are sometimes several different ways of conveying the same concept. The same thing applies with algebra. Algebra is a language, and therefore in algebra, many a times you will see, just like any other discipline, that there are several different ways of conveying, saying the same thing. A to the fourth. A to the fourth, or A raised to the fourth power. A raised to the fourth power. There's another one. This thing can be raised as p cubed. P cubed, p raised to the third power, or p to the third, same thing. Like I said, this is our beginning part, so I'm explaining all this thing in details, but of course as we go along, we're not going to keep explaining the same thing over and over again. Do you understand? Let's go to the second problem we have for today. Just give me 1 second. I'll be right back in the camera within 30 seconds. I'm right here in the room. I just have to take care of something. Here's the second problem for today. Four p squared times 3 times p raised to the fourth. 4p squared times p raised to the fourth. Again, 4 times 3 is 12, and now we have p squared times p to the fourth. P squared times p to the fourth, as we already saw, p squared times p to the fourth is going to be same as p raised to 2 plus 4. Why? Because p squared is p times p, and p to the fourth is p times p times p times p. So as you can see, p is being multiplied by itself 6 times, which is what the exponent tells us. This exponent of 6 tells us that p is to be multiplied, this quantity p, whatever the p happens to be, it is to be multiplied 6 times by itself, p to the fourth. So that's it, the final answer is 12 p raised to the sixth. You see again, p raised to the sixth. I did not say p raised to the sixth power because I'm lazy. P raised to the sixth. Nobody bothers to say power. Or p raised to the sixth exponent. Nobody says that. Do you understand? P raised to the sixth, that's it. Let's go to the next one. Number 3. I'm going to actually erase both of these things so that it doesn't get too crowded and too low. Number 3. Two ab squared times 3a squared b. Now we have two variables. It's getting a little kinky. Do you understand? No, not kinky in that sense. Be nice. Alright. So here we have 2 times 3, which is simply 6. And then we have a times a cubed, and then we have b squared times b times b. Well, this is 6. A, now when you say a, it has an exponent of 1. This b has an exponent of 1. So again, a to the first power times a to the second power times b to the second power, which is b times b times b. So it's basically 6 a raised to third, b raised to third, which we could have very easily figured out from here. 1 plus 2 is 3. As I said, when the base is the same, all we have to do is add the exponent. When the base is the same, all we have to do is to simply add be exponents. Voila. We'll leave it here. But the base has to be the same, you understand? Let me give you a numerical example to make you understand. Let me give you a numerical example to make you understand why the base has to be the same. For example, if somebody asks you how much is 2 squared times 2 cubed, well, this is going to be same as, because the base is the same, it's just 2 plus 3, 2 raised to 5th. Now, what is 2 raised to 5th equal to? 2 raised to 5th equals to 2 being multiplied by itself 5 times. 2 times 2 times 2 times 2 times 2. Let's see what we get. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So 2 raised to 5th is 32. Let's see what this gives us actually. Here we had 2 squared times 2 to the third. 2 squared is 4 and 2 to the third is 2 times 2 is 4, 4 times 2 is 8, 8 times 4 is 32. Voila, you see we get the same answer. This is 32. But what would have happened if the bases were different? Well, if the bases were different, nothing would have happened. We would not be able to do this thing. None of this will apply. None of this will apply. Let's do an example where the bases are different. 3 raised to first times 2 raised to 2. Well, the bases are different. Here we cannot say 3 raised to 3, nor can we say 2 raised to 3, because both of these answers are wrong. Because 3 times 1 is 3, 2 squared is 4, which gives us 12. Neither of the answer is correct, because 3 raised to 3 is 3 times 3 times 3, which is 27, which of course is wrong, because as we saw it's 12. And 2 cubed is 2 times 2 times 2, which is 8, which is also wrong. So if the bases are different, then the exponents do not apply. The rule of exponents does not apply. We cannot simply add up the exponents, because the question is, whose exponents are you going to add up? You're going to add up the exponents of 3 and the 1 together, or 3 and the 2 together. It makes no sense, because this quantity 3 times 3 raised to 1 times 2 squared is neither 2 cubed nor 3 cubed. This doesn't apply. Do you understand? So the base has to be the same. As long as the base is the same. This is called the base. We never introduced this concept. Four raised to 3, 4 is called base. 3 is called exponent. And if we had 5 times 4 raised to 3, then 5 would have been called coefficient. Now let me give you the same example in terms of variable. If we had a times x to the third, a is your coefficient, x is your base, and 3 is your exponent. What number were we at? I forget now. Oh, this is no good. Let's do number 4. I think we were on number 4. Yeah, we were on number 4 because I did 2 of them. Then I erased the blackboard and now I was going to do 2 more. So we are on number 4. 4a cubed times 5a squared. 4 times 5, 4 times 5 is 20. And then we have a cubed times a squared. A cubed times a squared. A cubed is same as a times a times a, and a squared, this comes from here, and then a squared would be a times a. So basically it's a being multiplied 5 times, which is same as 20 a raised to 3 plus 2, or a raised to the 5th power. A raised to the 5th power. Do you understand? And of course I'm not going to show all these intermediate steps all the time. As we after a few problems you will begin to get a hang of it. Okay? So if you want to do it, if you want to do the same problem in a more straightforward manner, this is how we would do it, without showing all the intermediate steps. If somebody simply asks you how much is 4a cubed times 5a squared, well, it's simply 4 times 5, which is 20, and a cubed times a squared is a raised to 3 plus 2, which is 20, a raised to 5th. Voila. You understand? Very good. I'll see you tomorrow on day number 52. Alright? Okay. Bye now.